Welcome back, folks, to another session of Euclidean geometry. I'm now going to prove the theorem that states that the angle subtended by an arc of a circle at center is twice the angle subtended by the same arc at any point on the circumference of the circle. Let's talk about the arc first. Remember, the arc is from A right round there up to B, which is subtending angle O at the center of this circle, and you've got arc AB again subtending angle C on the circumference of the circle. Go to the next diagram. We've got the major, I want to stress this, the major arc AB subtending this angle at center. Then the very same major arc AB is subtending that angle at the circumference of the circle. Now the theorem says this angle is twice that angle, and this angle is twice that angle. We are now going to prove that theorem. Folks, as a reason, when you apply this theorem, you just tell us that the angle at center is twice the angle at the circumference. Then you shall have reason for using this particular theorem. How do we prove it? We give you a circle with center O. There's your circle with center O, circle with center O. With arc AB, you've got your arc AB, you've got your arc AB. There's a minor and a major arc. Subtending angle AOB and angle ACB. The arc AB is subtending angle AOB, this angle, also subtending angle ACB, that angle. Your major arc is subtending angle AOB, this angle, subtending angle ACB, that angle. Now, for this theorem, there are three diagrams that are normally given for the proof of this theorem. I'm going to use these two because they are the same in the proof following sequence. Now, if you look at this particular theorem, it would mean now that we have to construct, as I'm proving the theorem, I'm going to say construction. I want to remind you again of the fact that we construct so that we end up having the previous theorem in proving the new theorem. Construction, we are going to draw CO produced to E in both diagrams. I'm now going to do that. I'm going to draw CO produced to E. In the first diagram, there's C to O being produced to E. Second diagram, there's C to O being produced to E. Now, let's see what we have done. Do you see that I have a line from center to circumference? Line from center to circumference, from center to circumference. What do we know about these lines? They are known as radii. And they are radii from the same point, therefore it means that these lines would be equal. The very same applies there. Those are radius from the same point. Now, which theorem up to so far we have brought into the new one? It is the theorem that states that angles opposite equal sides are the same. That means that angle C1 is going to be equal to angle A. That means that angle C2 is going to be equal to angle B. Let's do the same there. Angle C1 and angle C2. Let's have O1 and O2, angle O1 and angle O2. Another theorem that we have brought to life is the theorem that states that if a triangle is drawn and one side is produced to any point, the exterior angle of that triangle would be equal to the sum of the two interior opposite angles. Let's look at that. There we've got triangle AOC with CO produced to E. That means angle C, angle O1, is equal to angle A plus angle C1. Now, let's prove this theorem now. I'm going to start by saying, we know that, sorry, not the angle there, we know that AO is equals to OC, which is equals to OA. How do we know this? I repeat again. OC is equals to OA, which is equals to OB. I was supposed to have said OB. How do we know this? These are radius from the same point. It applies in this triangle, it applies in that particular diagram. Diagram A, diagram B, the same thing. Now from this, we can now say, from this reason, angle C1 is equal to angle A. Now, folks, be careful. Angle C1 is equal to angle A. Even in that diagram, angle C1 is equal to angle A. What is your reason? These two angles are angles opposite equal sides. That's beautiful now. From the two statements, I'm now gonna say, but angle O1 is known to be equals to angle A plus angle C1. I'm talking about this angle. It is the sum of these two interior opposite angles. I'm talking about that angle. It is the sum of those two interior opposite angles. Now, that reason would be exterior angle of a triangle is equal to the sum of the two interior opposite angles. Let's look at what we want to prove here, because it will always guide us. Do you see that? I've got angle A plus angle C1, which is compared to angle O. But in the proof, they say I must compare O and C, the two angles, not A. Now, how do I get rid of that A? Do I take my T-Pex and remove it? No. In mathematics, we don't do that. We go back to our previous statement. We said angle C1 is equals to angle A, meaning that where I see angle A, I can put angle C1. There we go. Angle O1 is therefore equals to, because angle A is equals to angle C1, is therefore equals to angle C1 plus angle C1. Beautiful. Now we can see that we are adding two things which are the same. That is why I'm going to say angle O1 is equals to twice angle C1, because C1 plus C1 is 2C1. Folks, you look at this logical reasoning. This triangle, which is exactly the same as that triangle, will follow the same logic. This triangle, which is exactly the same as that triangle, will follow the same logic. What am I saying now? I'm saying to you, similarly, beautiful English in mathematics, similarly, if I can take triangle COB with CO produced to E, I would get angle O2, I'm talking about this one, which is equals to this angle plus that angle. But this angle is equals to that angle, meaning that now when I replace B by C, I would get twice angle C2. How beautiful is this? Now, up to so far, I have proved that this piece is twice that piece, and this piece is twice that piece. But now, here they say, prove the whole. Prove the whole that is twice the whole there. Prove that the whole angle is twice the whole angle. Now, I have divided this into two pieces. How do I make a whole in mathematics? Ah, beautiful, beautiful. That is why I love mathematics. You cut, you put together again. Mathematically speaking, I can say angle O1 plus angle O2 is therefore equals to twice angle C1 plus twice angle C2. Remember that angle O1 is twice angle C1. If I add O1 to O2, which is twice angle C2, I would get exactly that. Now, when I add these two, I get the big angle AOC. Not angle AOC, the big angle AOB, because I'm adding this to that, folks, which is equals to, now I've got twice angle C1 plus twice angle C2. Do you agree with me that this is exactly the same as highest common factor being removed 2 into angle C1 plus angle C2? Now, that would mean we have the 2 there, which is that one. Now let's see what we have done there. We have put together angle C1 and angle C2. Angle C1 and angle C2. Put them together. What are we going to get? We are going to get the big, beautiful whole. Angle ACB. Aha! We have proved that theorem which states that the angle at center is twice the angle at the circumference. If you don't believe this, I can even prove it to you practically, because I know that other people normally look at this and say, but what are these guys saying? What do they mean? Is it true or not? You see, if I take this, I put it there, and we trace this angle. Aha, beautiful mathematics being put into practice. Let's see what we have done. I did not do anything there. Let's put it back again. There we go. There we go. You see, it covers the whole angle. Let's put it here and see what happens. It covers half of it. Now it means I'm going to leave this one here and take another one again. I don't want you to say he's cheating. You see, this one is written both sides. Now let's measure that angle again. My beautiful folks, I want to show you that we are not feeding you false information. There we go. I'm going to fold it right in front of you so that you don't say that, he's cheating. Now, let's see. Remember, this was from there. And this also is from there. What are we doing now? We are demonstrating the fact that this angle is 2 times that. When we put them here, we can see that this covers half of it. We put this one there. We can see that this now is covering the whole angle. That means the angle at center is twice the angle at the circumference. Thank you very much, folks. Beautiful mates.